Today's lesson's on multi-step ratios, and the learning goal says, use proportional relationships to solve multi-step ratio and percent problems. Examples of this are going to be multi-step ratios, percent error, tax and tip, markups, markdowns, and real-world problems. All of these kinds of examples have to do with ratios, whether it be in the form of percents or some more real-world kind of shopping examples. You will see ratios and the ratio setup in all of these types of problems. So I just want to make sure that you're aware that whenever we're looking at these kinds of problems, we're pretty much setting up a fractional proportion. So this is very similar to when we look at triangles, to when we look at an example like x over 2 equals 4 over 6 and you solve for x. Any of that kind of work that we've been doing, this is where it's going to be applied. So the first type of problem we're going to look at is a multi-step ratio and percent problem. And the problem says a microwave's temperature increases by 25 degrees every 2 minutes. What would its temperature increase after 5 minutes? Okay, so again, we're looking at fractional proportions. So I'm going to compare minutes to degrees. And when I talk about minutes to degrees, I have one set of information that is complete. I know that there are 25 degrees for every 2 minutes. And that is going to equal the same proportion as if I pursued heating the microwave for 5 minutes. But I'm not sure what the temperature would be at that point, so I'm going to put an x as my variable. Now, some of you may be able to look at this problem and say, okay, in order to get from 2 to 5, I would blah, 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 and I would do my proportion, and I would figure out what x is. But when I look at it, that seems a little too complicated, and so I want to cross-multiply. Again, when I cross-multiply, I take the numerator of the first problem, and I multiply it by the denominator of the second problem. So 2 times x is 2x. And that's going to be equal to the numerator of the second problem times the denominator of the first, 5 times 25. Five times 25 is 125, so 2x equals 125. Now, if 2 x's are equal to 125, then 1x is going to be equal to 125 divided by 2. When I divide 2 by 2, I get 1, and 1 times x is just 1x. That's going to equal 125 divided by 2, 62.5. So what was the problem? It wanted to know, what would the temperature increase be after 5 minutes? Well, the temperature increase would be 62.5 degrees. Again, I was able to solve this problem just by setting up a ratio proportion as a fraction. The next problem says gratuities and commissions, fees, and tax. This is all about paying tax, paying an additional percentage on an amount that we are already familiar with. So in this case specifically, Mason paid $11.12 for a pair of shoes. This amount includes a tax of 4%. What was the cost of the item before tax? First of all, we have to think about percents as being a number over 100. 100% is equal to 1 whole. And you should remember this from 6th grade or 5th grade math. So if the cost of the shoes compares to the percent tax, in this case specifically, my cost is $11.12, and that's including a sales tax of 4%, right? So I'm not going to have a percentage of 100 in my denominator. I'm going to have a percentage of 100 104 because my $11 includes 4% sales tax. So I'm going to add that 4% onto my 100%. I want to know what was the cost of the item before tax. What was the full cost of the item before I added my tax? So that would be just the total 100%. Again, I'm going to use my strategy for cross multiplying. $11.12 times 100 is going to give me 1,112. And that's going to be equal to x times 104, which is 104 x's. Again, if 104 x's are equal to 1,112, then 1x independently we can find out by dividing 1,112 by 104, which would equal $10.69 per pair of shoes. Percent error and percent increase. Natalie's yoga class had 150 students yesterday. She did make a mistake in counting students and recorded the number as 200 students. And I believe the question, though it seems to be incomplete, is what was her percentage of error? So the number of students over the students counted is important information for me. Actually, we might want to think about the number of students over percentage, right? Because we're trying to find out what the percentage of error is. So in this case, there are 150 students compared to 200 students. The actual number of students is 150. So that's going to be equal to my 100%. I want to know what the percentage is if the number of students was actually 200. So again, we're going to cross multiply. 150 times x is 150 x's. Compared to 200 times 100 is 20,000. Now remember, I'm multiplying these numbers rather quickly because I know that 2 times 1 is 2, and I have 1, 2, 3, 4 zeros in addition to that. So I just use a quick shortcut that I know in order to figure that out. Lastly, I want to remember if 150 x's are equal to 20,000, what is 1x equal to? In order to find that, I divide by 150 on both sides. And I find out that x is equal to 133, and there's a decimal here, 0.3 repeating. So what does that tell me? I want to know what is the percentage of error. Well, what should a percentage be? It should be 100%. However, the percentage that was calculated is 133.3 repeating. If I remove the 100% that I think I should have, then my percentage of error is 33.3. This is how much extra percentage I calculated, even though there was no people to really account for that. So if you take a look at the problem, I started with 150 students at 100%, but I counted 200 by accident. So I want to know what is the percentage of the amount of error that I made. And this really makes sense because 150 is 3/4 or 3/4 of 200. So to add that additional 33% seems to be clear. The next problem says markups and markdowns in word problems. Sam buys a lamp during the sale. There was a discount of 20%. If the original price is $4, what is the sale price? This should be pretty straightforward. At the original price of $4, we're talking about the whole 100%. This is going to be equal to the sale price, which we're not sure of, but there's a discount of 20%. To take a discount of 20% from 100, I remove 20% or subtract 20% and get 80%. Again, cross multiply. 4 times 80 is 320 equals x times 100 is 100 x's. So I want to know what is the sale price. To account for 1x rather than 100, I divide both sides by 100. So I get x is equal to $3.20. So my sale price is $3.20, which seems to make sense. When I look at it, if I started with a price of $4 and it's 20% off, it makes sense that it'd be about $3, give or take. So you want to make sure that you're also justifying your answers and thinking about, does this actually make sense? Could this happen in the real world? Does 20% of $4 sound like it would be more than or less than $3.20? Our last example is a real world problem, and it says Julia made $36 in an hour. She gets a 10% raise. She works 40 hours a week. How much more money will she make this week as a result of her raise? This is an extended multi-step problem, so there's a couple of things we need to figure out here. The first is that she's making $36 an hour, and she works 40 hours a week. So 36 times 40 is going to give us the total number of hours that she works a week. So I'm going to do this out. So we have 144 hours, $36 an hour times 40 hours a week is $1,440 that she makes per week. Right now, right? So right now, she makes $1,440 per week, and that's her 100% paycheck. But she gets a 10% raise. A 10% raise would be 110%, right? So we go from 100% to 110, that's a 10% raise. And we need to figure out how much money is she going to make now. So we do our cross multiplying. 1,440 times 110% is equal to, this is a big number, 158,400. And that's equal to 100 times x. Don't forget, we finished cross multiplying. In order to figure out what x is, we divide both sides by 100, and we get $1,584 per week. So her original pay or income was $1,440 a week, but now she's making $1,584 a week. In these problems specifically, it's really important to pay attention to what the question is asking. How much more money will she make this week as a result of her raise? So I need to actually find the difference between $1,584 and $1,440. That's a quick subtraction problem. 4 minus 0 is 4, 8 minus 4 is 4, 5 minus 4 is 1, and 1 minus 1 is 0. So she's making an increased pay of $144 per week. Again, that's more of a challenge problem that you'll see maybe on a test for extra credit. Your proof is on the board. Donovan took a math test and got 35 correct and 10 incorrect. What was the percentage of correct answers? And it says round to the nearest hundredth.